So there are many types of servers. This on this slide is just a partial list, right? I mentioned other types already, the data loss prevention or DLP servers, or perhaps a firewall server, sometimes abbreviated FW. So these are types of servers on the last slide. There's also, for example, a domain name service or DNS server. I discussed that a little bit in chapter 2. We also discussed there the FTP server, the File Transfer Protocol server. Now, just to touch on the DNS server real quick, the DNS server is often placed in a demilitarized zone. I kind of show that on the slide on the right. So I have my servers on the left-hand slide of that right picture. I have my servers on premises. Then I have this demilitarized zone, which has extra protections, but it's not completely open to the internet. It's actually limiting some traffic from the internet, figuring out what is what. So a DNS server or domain name service server is often placed in a demilitarized zone or a DMZ. And in terms of computer security, a DMZ network functions as kind of this sub-network containing the organization's exposed outward-facing services. So these are exposed outward-facing services that we want to give a little extra protection to. And so it acts as the exposed point to the untrusted networks commonly found on the internet, right? Other types of servers that we can add to this list are load balancers or even LDAP servers or a virtual service. So the list can go on and on. These are some very good summary for an initial look. Now, continuing with this, server virtualization is actually the process of using software on a physical server to create multiple virtual instances of a server, each capable of running independently. So I am going to use one actual server, a real server, but that software is going to create multiple servers from it, each operating independently. So a server then administers users using this virtualization software to partition one physical server, like I said, into multiple isolated virtual environments, right? A server farm or a server cluster is a collection of computer servers. There's a picture at the bottom of this slide. It usually is maintained by an organization to supply server functionality far beyond the capability of a single machine. So a server farm often consists of thousands of computers which require a large amount of power to run. It requires a large amount of power to keep cool. There will be rules for cold walls and warm walls and how you face them as they try and stay cool, etc. That's beyond this course. It's really in a Security Plus course or something, but very interesting. And then there's a mainframe. A mainframe is going to handle hundreds or thousands of connected users simultaneously. Now, continuing with terminals, right? A terminal is a computer that sends and receives info from a server, or we refer to a server also as a host computer. And this really differentiates it from a thin client, which basically is a limited desktop, often found in public locations, right? Such as libraries or schools. That's a thin client. In the business world, when it comes to security, kiosks often generally get overlooked. We think of computers, laptops, phones, servers. What about kiosks, right? They're also computers. Just like we need antivirus for our computers and servers, we want to make sure, for example, we have antivirus protection on our kiosks. Or who can they reach out to and talk to on the internet? We want to limit that because it's kind of an automated function. So, and kiosks, of course, can have a special features that you'll want to discuss with your technologist, like antivirus, like who the server can talk to, what administrative rights does it have, etc. And then there's even a smart kiosk. A smart kiosk is kind of a new product. the company I work with. It's designed to provide citizens, visitors, passersby, whoever, with access to information and city services, right? And so a smart kiosk typically has an interactive screen that allows users to easily seek and find information they need using this computer. And this is, again, one of the services that my company has been working to deploy. Now, we have also a POS, sometimes a point of sale terminal, POS. Many of us have used this whenever we check out at Walmart. Don't want to use the regular line. We want to use the self-service line. We're using a POS, a point of service, point of sale terminal. Think about it before you even answer it. Can you list some of the inputs and outputs that this computer is going to process for you? Just think about it. Like, for example, a barcode reader as an input device that uses laser beams to read the barcodes. And then as an output, you have, it's going to be on the screen, the output of the cost before you finalize your purchase. And then it's going to have another output, would be the receipt, the printed receipt you might use. Think of this. It's going to record the sales record internally besides your receipt. It's going to update the inventory. It's going to verify your credit before you check out and do other activities. Marvelous capability, and even provide change, right? Okay, very interesting. Now we have also an ATM. We've all used ATM type machines, right? An ATM connects to some host computer, right? We said a host was some special server or focus server. So a host computer through the network. Well, with ATMs, like other machines, for example, at gas pumps are very similar. I want you to be cautious of skimmers. Skimmers are really thieves that capture credit card numbers and PINs by placing a skimmer on the ATM or on the gas pump itself, right? Some even sophisticated skimmers have Bluetooth-enabled capabilities, right? Sometimes they're just less technical devices like false card readers. I have a picture of that here on the right in green that can pick up your secure card data, and then they have a little camera. They're looking to see your PIN as you punch it in. So skimming is illegal practice, but it happens. And so what I'd like you to do is consider when you go to the gas pump, wiggle the credit card machine. If there's a skimmer on it, it's probably going to be loose. Wiggle that a little bit. And then, of course, when you punch in your PIN, put your hand over it and punch it in. Hide those credentials from a would-be fraudster. Okay. Now, in this, it is common that web apps, of course, extend the capability of kiosks that we were talking about, and performing many of the same functions. I mentioned a smart kiosk, right, is a kind that I was talking about before. It's kind of digital signage, right? It's this interactive screen that can be installed in public spaces to provide users with a wealth of information and services. I mentioned a smart kiosk is something that my company is looking to deploy in cities around the world, right? It can share smart city initiatives, solve urban challenges through data and technology, collect data on services and assets and resources using sensors and this Internet of Things devices, which we'll talk about in a few minutes. With the goal being to improve the quality of life for residents. Really kind of exciting, the world that you are participating in. Now we also have supercomputers. These machines do complex calculations, and they do them very rapidly. A supercomputer is a computer with a high level of performance as compared to a general purpose computer. The performance of a supercomputer is commonly measured in floating point operations per second, or flops, where our regular computers, we usually talk about it in million instructions per second, or MIPS. So we're transitioning from MIPS, or million instructions per second, to flops, floating point operations per second. It's kind of how they're measured. Supercomputers play a very important role in the field of, say, computational science, used in a wide range of computation-intensive tasks, like in quantum mechanics and weather forecasting, climate research, oil and gas exploration, molecular modeling, and others. Very, very interesting what, through computer science, what we're able to contribute to those other disciplines. Now, cloud computing is the on-demand availability of computer system resources. When I say on-demand, because normally our resources are on-premises, but these are on-demand. They're easily expandable and collapsible because they're in the cloud, they're in the internet. So especially for things like data storage and computing power. And so the term is generally used to describe a data center's availability to many users over the internet, right? So this is different, as I mentioned, than the traditional model where we can access our resources and services locally. We might call that, computer speak, on-prem or on-premises, right? Now it's not local anymore. It's in the cloud. It's in the internet, saved elsewhere. So cloud computing allows a company to diversify its network and its security infrastructure, right? It's scalable, right? Because now this third party takes care of the hardware, the software, the licensing oftentimes, right? Even the security, you want to mention that. So hardware, software, licensing, and security. Those are kind of conversations you always want to have with a cloud vendor. Cloud computing implies this, it's a virtual approach, it's virtualization. And like I said, it provides that scalability or elasticity of IT services. I can expand and contract them very quickly, right? And we want to approach cloud data storage cautiously. There are many customers sharing the same cloud computing. And as a third party, I also want to ensure that the cloud is audited regularly to dispel or confirm the risk and the rumors of risk, right? Be aware that if I cloud compute on a cloud and somebody bad is using that cloud and the police have a warrant for the data on that cloud, they're going to get my data too. So I prefer to have my own instance of storage on my own cloud, separate from, say, a public cloud, for instance. There are many forms: public cloud, private cloud, corporate cloud, etc. But many people go public cloud because it's cheaper, but there are risks. Just be aware. Then a smartphone. Recall that mobile phones are held in our hand. So smartphone now is a type of mobile phone, and it's also a multi-purpose computing device, right? It has many distinguishing features. They have stronger hardware capabilities, better operating systems, the software, the internet, the browsing, the multimedia capability like video files, cameras, gaming they can do, alongside their core phone functions like voice calls and text messaging. Many of them will also use near-field communications, NFC. Near-field communications are devices automatically connect when they're in range. So NFC is often used with mobile payment systems of smartphones, right, where you hold your smartphone up to the payment object at the store. That's using NFC communications, near field communications, right? Be aware that some security issues can arise if someone loses your phone, or if the phone is stolen or compromised in some other way. We may want to be able to swipe our phone clean. Okay, that is going to be it for part 2 of chapter 3. We'll come back with part 3 in a moment, continuing with mobile devices and texting.